Hello world, I'm Brian, and let's walk through the Wait For It challenge. In Wait For It, you were asked to take in a number of passengers that we would give you via standard input, where we tell you when each passenger would arrive at a bus stop in a 60-minute interval. And you were tasked with figuring out when 3 buses should arrive in order to pick up these passengers, so that every passenger got picked up, and so that we minimize the total amount of waiting time, where waiting time is defined as the sum of the amount of time that each passenger would have to wait before being able to take a bus to their next location. So let's start thinking about the logic we can use in order to figure out how we might determine what the optimal bus times for arrival are. One thing we can tell is that it doesn't make sense for a bus to show up in between times the passengers are arriving, or to ever arrive at a time that a passenger is not also arriving at. Because if a passenger were arriving at 24 minutes and no bus were to be arriving until 25 minutes, then that bus could just as easily have arrived at 24 minutes and picked up all of the same passengers. Once we know that, we can also figure out that the last bus should only ever arrive at the same time that the last passenger is arriving at the bus stop. Any earlier, and the last passenger would miss all the buses altogether, and any later, and it would just be extra time that the bus is going to have to wait for no reason at all. With that in mind, we can start to think about how we might calculate the optimal time. And let's take a look at the code that we might write in order to do this. One thing that's going to be valuable initially is writing a function, in this case called waitTime, that takes in a list of passengers and a sample set of times and calculates the total wait time that these passengers would have to wait in order to take these buses at these given times. So we start with a total waiting time of 0, and we're going to iterate over each passenger in our array of passengers. We'll start by setting each passenger's wait time to -1, because we know that that's a value that they'll never be, because at minimum, a passenger is going to wait 0 minutes in order to get a bus that arrives at the same time that they do. Then, we're going to check each bus time, starting with the earliest bus. And once we've found a time that works, in other words, found a bus time that is greater than or equal to the time that the passenger is arriving, then we can remember the amount of time that they have to wait and then break out of this loop because we found a bus for them. If the wait time is still -1, then we know that we didn't find a bus for this particular passenger. All the buses arrived earlier than they did, and so we return -1 to indicate a failure. But otherwise, if they were successful, we can add their wait time to the total amount of waiting time, and then after iterating through all of the passengers, return the total amount of waiting time. Now, we have a function that, given passengers and given a set of bus times, can calculate how much time these passengers would have to wait in order to take the bus. Now, we can start testing to find the optimal solution. In our main function, we start by getting via standard input the number of passengers, and then taking in each passenger's time at which they're arriving at the bus stop. Now, we're going to create a value called optimal time, which will store the optimal time we found so far in terms of total waiting time, and an optimal solution. Remember that we know that the last bus should definitely arrive at the same time as the last passenger. So we know that the value of the second index of optimal solution is going to be the last element in the passengers array. Now all we need to do is figure out the other 2 values in the optimal solutions array. So, since we know it would be inefficient for a bus to arrive at a time when no passengers are arriving, we can just iterate over all of the passenger times within the first few buses. So we'll have 2 sets of nested loops. First, iterating through all of the passengers in the first element of the array, and then, once again, iterating for the second element in our optimal solutions array. We'll create a test array that's going to create a set of 3 possible bus times that are going to be equal to the first value, the second value, and the third value, which we already know. And then we'll compute the wait time for this set of passengers and the 3 times that we're trying to test. If that calculated wait time was not a failure, in other words, not -1, and also either better than the previous optimal time, or it's the first test, in which point optimal time would be -1, then we found a better time than we found previously. So we can remember our current wait time as the new optimal time, and update our optimal solution, so that the 0 and 1 indexes of optimal solution are equal to the 0 and 1 indexes of the one we just tested. After iterating through all of the possibilities, the result is that optimal solution will contain the 3 bus times that are the optimal waiting time. And now we can iterate through our optimal solutions array, and each time print out an optimal solution. So now finally, if we were to run this program via /wait for it, type in a number of passengers, like 6, and type in 6 times the passengers might be arriving at the bus stop, say 3, 5, 6, 23, 24, and 51. The result is that the 3 optimal bus times are at 6 minutes, 24 minutes, and 51 minutes. This was wait for it.